Okay, everyone, we're going to look at number 7 in section 7.3. We're going to evaluate this integral using trigonometric substitution. So first of all, you might notice, generally speaking, a couple ways you could do this, but we usually have been looking at integrals of the form x squared minus a squared. Okay, here we've got 5x squared minus 49. Maybe that's a squared. I'm going to do this this way. I'm going to factor out a 5 from in here first to see exactly what the a is. And then we have to determine, is it x equal a uh, sine theta? Is it x equal a secant theta or x equal a tangent theta? Okay. Well, let's do the factoring of the 5 out. Just this to the 1/2 power, of course, means the square root, right? So I'm going to factor out a 5. You say, how can you factor out a 5 from 49? Well, it's easy. You leave 49 fifths, right? If I multiply that by 5, that'll give me 49. And now 5 times this stuff in the parentheses, all to the 1/2 power. I can distribute the power, so this will be 5 to the 1/2 power, or square root of 5. And then all this stuff to the 1/2 power. So now do you see it's x squared minus a squared? So a squared is 49 fifths, or a is what? The square root of 49 is 7 over the square root of 5. So not a very appealing number maybe to you, but it's what you need for the coefficient. Now, what are we going to choose? Well, we're going to choose x equal a secant theta. And so you need to know that we do that when we have x squared minus a squared. And the reason that will be is we'll be able to simplify the radical expression here. Okay, so if x is 7 over the root 5 secant theta, here's dx, right? Just taking the derivative of that. And then here's the square root expression, right, that we have under here. Now x squared will be what? 49 fifths secant squared theta. I can factor that 49 fifths out, and then I'll be left with secant squared theta minus 1. And then I can write 49 fifths to the 1/2 power times the secant squared theta minus 1 to the 1/2 power. Secant squared theta minus 1 is tangent squared theta. And that's why we can use that substitution. If I chosen sine theta here, this would not work. Sine squared theta minus 1 doesn't get us anywhere. If this was tangent theta, again, tangent squared theta minus 1 doesn't get us anywhere. But tangent squared theta is what we get, and the square root of tangent squared theta is just tangent. Of course, the square root of 49 fifths is back to 7 divided by root 5. So that's what we're going to replace this expression here with. Before we go on and do that substitution, just note, since x is 7 over root 5 times secant theta, I can multiply by the reciprocal, square root of 5 over 7 on both sides to get this relationship. And remember, secant, which is the reciprocal of cosine, cosine is adjacent over hypotenuse. So this means this is hypotenuse over adjacent. So if I draw my right triangle here, where theta is the acute angle here, the adjacent, the hypotenuse over the adjacent, hypotenuse is this quantity, the top, and the bottom is the adjacent. And then I can solve for this side opposite here by the Pythagorean theorem. 7 squared plus b squared would be equal to this quantity squared, which of course is 5x squared. Subtract 49 and then take the square root, and we get this, which is not surprising looking at the original integral that we started with. Okay, so let's do the substitution. We've got x squared. Remember, x is this. If I square that, I get 49 fifths secant squared theta. So that's what I put up here. And then I've got dx. And of course, we computed our dx here, so I'm going to copy that down for the dx. Right there, there's the dx. All right, and this right here was the x squared. Okay, so I've got x squared dx, and then down the bottom I've got square root of 5. There's my square root of 5. And then this x squared minus 49 fifths to the 1/2 power, right, we calculate to be this quantity, 7 over root 5 times tangent theta. All right, it's a lot going on, but it kind of simplifies down a little bit. I can divide top and bottom by 7 over root 5. I can divide top and bottom by tangent theta. And then I can bring out the 49 fifths divided by root 5 as 49 over 5 times root 5. And I've got secant squared times secant, which is secant cubed. Okay, so how am I going to proceed there? Because secant cubed is, if it was secant squared, we'd be set, right? Because that is going to be, the antiderivative would be tangent theta. So what we're going to use is our table of trig integrals has a reduction 1 for powers of secant. So that's what I'm going to use this one with m equal 3 in this case. I'll have 1 over what m minus 1 is 3 minus 1 is 1 half tangent x, 3 minus 1, 3 minus 2 is 1 secant x, and then I get 1 half secant to what? The first power, or just secant x. And so that's what I've done, applied here. Of course, instead of x, we're talking about theta, but there is using that that formula. Now, what about the antiderivative of secant theta? Well, we did derive that one in class, but I would probably help you out a little bit with that one. Here it is. So secant theta will be the natural log absolute value of secant theta plus tangent theta, and that's what we have. Right here. So I've got, don't forget, I've got this constant multiple out here. I'll bring that out. Got 1 half tangent theta secant theta plus 1 half, and then who said the antiderivative of secant theta is this. Okay, so now I'm all in terms of theta. I'm going to do a little bit of cleaning up here. First of all, I'm going to distribute through this constant multiple. And of course, the 2 times 5 gives me a 10 down there. And in both cases, actually, because I'm multiplying by 1 half each time. Now, we're ready to go back to the variable x. So remember how we do that. We go back to our right triangle, and we need to know what tangent and secant are. Of course, we already know what secant theta is, right? Secant theta is the square root of 5x over 7. Tangent theta, sorry, is opposite over adjacent. So opposite is this quantity, and the adjacent is this. So we get that for our tangent theta. And there, as we said, is our secant theta. So I'm just going to simply replace tangent theta with this and secant theta with that in both locations. Okay, so we've got a lot going on here, but can we simplify? Well, yeah, we can. Notice 7 times 7 is 49, so we can get rid of all those. Here I've got a square root of 5 down here and a square root of 5 up here. And so I'm just left with 1 over 10. I'll bring this x to the front, square root of 5x squared minus 49. Here, I've got two fractions with a common denominator. I can combine them as one fraction. Now, this would be an acceptable answer, but we can simplify it, and that's what Achieve is going to be looking for. How can we simplify it? Recall properties of logarithms. The natural log of a divided by b is just the difference of the logarithms, right? Remember, logarithms being exponents, that's what we do when we divide like bases to different powers, we subtract the exponents. So here the a is the numerator and b is just 7. So the log of a over b will be the log of a, I put that in absolute value bars, minus log of b. And if I distribute this over both of those, I get the following down here. Okay, so it's 49 over 10 root 5 times each of those things. And I'll just have you look at this expression here. There's no x here. This is a constant. And so if I have some constant plus some arbitrary constant, what's that all going to be? Some arbitrary constant. So I'm going to call, so again, this c right here is not the same as this c. We've sort of absorbed this constant into that c. It's still a constant. Okay, it's still constant. So it's still so this is what we get, right? It looks almost exactly like we got up here, except we just have the natural log of this stuff, not all over 7, because we can combine that, absorb that in. And that's actually part of the instructions. If you read and Achieve, they'll say to express your antiderivative by absorbing the into C as much as possible. So what do they mean by absorbing into C as much as possible? Here's what they mean. Absorb this constant into that. Okay. Now, this is the answer, what I expect you to write. I noticed in Achieve, this is what they have written. For some reason, they factored out an additional 1 over root 5, which would require a root 5 here since we don't have it. And of course, the 10 over root 5 coming out here leaves a 49. But then I also noticed that when you have the natural log absolute value, you have to have an additional parentheses because it's looking for the argument for the input to the logarithm. And so you have this weird bracket, parentheses rather, and then the absolute value bars on that. So looks a little bit different in Achieve. Let me know if you're having troubles with this. Hopefully this is helpful for you.